This project could be used if you don't want an animal like in a certain area, or you want it not to go in a certain area. It could be used to deter the animal from the area, as you can see here. Group and Coach L's EMD class. I am running this program on this Arduino 101 right here. This program and board is being powered by this cable that is running into the tablet that I am recording the video on. This program uses an RGB LED right there, a servo motor, an ultrasonic, an LCD screen, a potentiometer, and a Piezo speaker right up there. This program that I'm using on this is a switch case statement that is using a series of switch cases based on how far away an object is from that ultrasonic. Everything is being powered and connected by those pins, and everything is also powered by 5 volts, and everything gets grounded. In this program, it is set to show the inches away that an object actually is. And this potentiometer also, if you turn it, increases and decreases the brightness of the LCD screen. And in this, it uses a series of switch cases to show how far away something is, but also to switch the colors of the RGB LED. And if it is closer than 3 inches, the servo motor will move 90 degrees. The Piezo speaker is also a factor in this, and it starts playing sound as soon as you are close enough to the project. This newspaper will be something going closer to the LCD screen. As soon as it goes within 10 inches, it will switch to green, and then if it gets closer than that, it switches to yellow. And then if you get closer than that, it switches to red. And if you are within 3 inches, this servo will move right there to block anything to get too close to the LCD screen, as shown here. Green, yellow, and then red. It blocks anything from coming close to it. And that is how my programming project 4 works with the switch case statements. I just finished updating my project 4, and now it does all the same stuff except for when you get in closer to the ultrasonic, it plays different tones to signify how close it is. This is the breadboard for my project 4. It is powered by this Arduino 101 right here. It uses a servo motor, an RGB LED, an ultrasonic, an LCD screen, potentiometer, 220 ohm resistor, and a Piezo speaker in the program itself. Everything in this power supply is being powered by 5 volts, which is coming out of right there, and everything is grounded through this grounding. These two boards are connected by these 2 wires. The servo motor is powered by the 5 volts that is coming out of the Arduino board, and it is connected through this pin that I can change what I want it to do, and it eventually gets grounded. This RGB LED is being grounded right there, but it also has 3 different pins in it, one for 3 different colors that you mix together, so you can make any color that you could want. Red, green, and blue are the 3 colors that if you mix them together you can make any color that you want. This is my ultrasonic, and my ultrasonic only has 3 pins. It just means that these 2 middle ones are connected, and it also has a power supply and a grounding wire. I'm actually using the pin ultrasonics XF instead of this HC one. And in this LCD screen, or also known as liquid crystal, I make it power through the 5 volts. That is coming from this Arduino. It also gets grounded, but it also has a variety of pins so you are allowed to change different characteristics, like what you want it to say, or what spot you want it to print out, what you want it to say. With this potentiometer, I regulate the brightness, and this is the 220 ohm resistor that helps it light up. This is just a normal Piezo speaker that I've connected to a pin so I can play any sound or tone that I want it to, and that's how it works in my program too. This is my schematic for my project. As you can see, everything is the same and looks the same as my breadboard version on Fritzing, and how I showed which pin it went to and which object it was. I switched the colors if it is going to a pin. So like the servo motor over on the left hand side, that pin color is yellow. For the RGB LED, everything is green, and so on for everything. And as you can see, it also is also the 101 board and the same ultrasonic I've used. Everything is the same except for it's a different way to look at what my breadboard actually looks like in a different way. And that's how it works. This is Lasse Struppe and Coach L's G Block EMD class at the Gloucester High School. I am doing my Ultra Sonic Range Finder program. This is, as you can see, it's written by me. In this project, I use a bunch of different objects, as you can call them. I use a servo motor, an LCD screen, an RGB LED, ultrasonic sensor, a potentiometer, and a Piezo speaker. The potentiometer I just used to alter the brightness, so it doesn't have anything to do with this program. I just thought I'd include it in there. Right here, this hashtag include means includes the library of the liquid crystal, which is the LCD screen. That lets me use and print out whatever I want. It also includes the servo library, which lets me move the servo motors around. As you can see here, the const in, which means it'll always be in that pin slot, is ping pin 10. So the pin for the ultrasonic. The liquid crystal LCD screen uses pins 12, 11, 5, 4, 3, 2. Speaker uses pin 13. The red pin for the RGB LED uses pin 9. The green pin for the RGB LED uses pin 8. The blue pin is pin 7. Because RGB means red, green, blue. In servo, so the servo pin is in pin 6. And servo 1 lets me access the servo and tell it what to do. In this program, I use switch case statements, which, based on the switch, whatever the switch is, lets me pick which case statement it goes into. And the way it does it for my program is it uses inches. And the way I figure out inches is through my ultrasonic, which uses long duration inches. Right here it uses pin low, so it makes it low for 2 microseconds. Then it's on high for 5 microseconds, then it's on low for 2 microseconds, and so on and so on. And using those readings from how long it takes for the ultrasonic wave to bounce back, it uses an algorithm down here called long microseconds to inches. it uses the microseconds it takes for the wave to get back to the ultrasonic to figure out the amount of inches away the object is from it. As you can see here, the microseconds is divided by 74, which is divided by 2, which lets it work that way. And then, as you can see here, the switch is in inches. The case is 0, so when the object is 0 inches away, it goes into that case. When it's 1 inch away, it goes in case 1, 2 inches away, case 2, and so on until it gets past 10 inches away, case 10, which means it goes into the default. Default means that if it's anything that's not within those cases, it automatically goes into that loop. And that's just how it works. As you can see here, I have break statements. Break statements lets the object break out of that loop, so then it can re-enter whichever loop the object is that it's that far away. Without this, it would not work, because if it didn't break out, it would just go down to the next case over and over, and it wouldn't actually work based on the amount of inches it would be away. It would just go into case 0, then automatically go in case 1, case 2. It wouldn't matter how far away the object is, it would just go into the next case until it got to default, which it would go back up to case 0, and it would just repeat that process, and it would be useless. And then, as you can see here, I set the cursor of the LCD screen to 0, 1, which means it goes into column, it goes into the next row, which is the second row, and it prints out the amount of inches it away for whatever case it's in. So if it's in case 0 right here, it prints out that it's 0 inches away. If it's in case 1, it prints out 1 inch away, and so on, until it gets to the default loop where it prints out this inches, which is the variable for how many inches away it actually is. I can't do it for if it's closer than that, because if it's in single digit numbers, the LCD screen, there's a glitch in it that it does not work. It prints out some other number attached on the end of it. And that's how it works. For the RGB LED, it's actually really interesting. It uses this set color method, which I found, that sets the color based on the red, the green, and the blue pin. As you can see here, once the red color, it goes 255, 0, 0, which means the red is all the way up. And if it's yellow, which is after, in this program, after it's more than 3 inches away, the RGB LED color switches to yellow, which would be 255, 0, 255, 0, which combines the red and the green color to make the yellow color. And then it's yellow for case 4 through case 6, when it gets to case 7, which is set color 0, 255, 0, it's the green color on the RGB until it gets to case 10, where it's a blue color, which is 0, 0, 255, and then for the default, it's defaultly a blue color. And this is the set color method that I'm using for it to work. It sets the color of the RGB that it works, that it sets the color, and with this method, you can also make your own custom specialized color that you want. And then another interesting thing about my project is that the tone. Tone is for the speaker, that it sets out the amount of hertz that the that the speaker uses. As you can see here, for the default, I'm using no tone, which basically sets the speaker to off. If I didn't have that and I tried to use the tone, it would not work. I use no tone until it gets to 6 inches away. Then I use tone speaker, which is the pin that the Piezo speaker is in. 500 hertz, and then 500 milliseconds it stays on longer, and it works better that way. It has a more accurate sound to it. And then as I get closer in inches to the ultrasonic, the hertz will go higher to notify you that it's getting closer and closer to the object. As you can see here, it goes up to 750 this time when it's at 5 inches away. 4 inches away, 1000. 3 inches away, 1250. 2 inches away, 1500. And 1 inch away, 2000. And it's the same for 0, because it's pretty hard to get to 0 inches away, so I just kept it as the same thing. In this program, I also use a servo motor, and the servo motor, I put it in that if the object is closer than 3 inches, it moves to protect itself from the object, well, to protect the ultrasonic screen. So as you can see here, servo 1 right is at 90. That means the servo goes to 90 degrees until it gets to case 3, where it's at 0 for the rest of the case statements. And that's pretty much how this works. It just goes from case how many inches away it is to into that loop where it does the amount. So like if the object was 6 inches away, the serial print monitor would say 6 inches away. The LCD screen would print out 6 to signify that the object was 6 inches away. The tone would go to 500 hertz to let you know how that it's that far away. It would set the color to yellow, the RGB LED color to yellow. The servo would be at 0 degrees, and it would print out all these serial print monitors. And that's pretty much how this works. Now on to the serial monitor for my project. This serial monitor just shows, like as you can see here, it's 15 inches away. The nearest object is 15 inches away. The LED is blue. The servo is at 0 degrees, and the speaker is off. If an object moves closer to it, as you can see, it gets closer and closer. And if it's at 8 inches away, the LED is green, the servo is at 0, and the speaker is off. But if you move closer than that, to let's say 2 inches, it prints out 2 inches away. The LED is red, the servo is at 0, and the speaker is on when it gets to that. And that's pretty much how this works. It just prints out the speaker, if it's on or off, what degrees the servo is at, what color the LED is on, and how far away in inches the object is.